So good evening everyone. Today we will start with convolution. We have been discussing about the convolution since long, where we have discussed that the output of any LTI system, it is being given by the convolution of the input and the impulse response of the filter or the system, right? Now, what is convolution and why it is important? So let's look over here. So in DSP, convolution is the fundamental mathematical operation which is used to determine the output of the system given an input signal and the system's impulse response, which we have already discussed. And it plays a crucial role in filtering, analyzing, and modifying the signals. Okay. Now, this is the definition of the convolution. Convolution is defined as the integral or the sum of the discrete sum in the discrete case, okay, of the product of two functions after one is reversed and shifted. This is important. One is reversed and shifted. In the context of DSP, these functions typically represent the input and the system's impulse response. Okay. So, since we are talking about the biomedical signal processing, and we have discussed that nowadays most of the biomedical signal processing, it happens in the digital domain, which is basically a discrete time signal. Okay, when we digitize a signal, it becomes discrete time signal. Okay, so we are mainly interested in the sum of the signal components after one has been reversed and shifted. Okay, so it is given by this equation, the discrete type convolution. It is given by yn equals to xn convolution of h of n, okay, which is again given by k equals to minus infinity to infinity x of k and h of n minus k. Okay, now this k, it allows us to take the signal into a separate time domain. Okay, so if you see this star, it denotes the convolution operation. In laboratory courses, yeah, in the exams, and while we are giving the questions, it is basically given in this form: a star for which is being encased within a circle. Okay, so that forms the convolution. However, in books you may find this star symbol as the convolution. Okay, so what are the steps in performing the discrete time convolution? So suppose we are given with xn, which is the input, okay, and hn is the impulse response. So when we find out yn, it is nothing but x of n convolution of h of n. Okay, now the one which comes at a later stage, it is reversed. Okay, typically the impulse response, because we usually say that y of n is equal to x of n convolution of h of n. So reverse mean we have to find out what? We have to find out h of minus n. We already discussed how to reverse the signal, right? Next is slide the flipped sequence across the input sequence xn. That we will see a bit later. Then when we are sliding it, at each position we'll be performing multiplication of the overlapping samples of the two sequences, and lastly we will do the summation at those positions to get yn or y values at particular n values. Okay, so I know it would be a bit difficult for you to understand at this moment, so please wait for some time. In few moments of time we will be discussing what is exactly happening. So properties of convolution, we have commutative x of n convolution of h of n, it is equal to h of n convolution of x of n. Now suppose I give you this equation, which signal I need to say reverse? xn I need to reverse. Okay, hn will be in the proper sequence. So whatever would be there in the second condition, that signal needs to be reversed to get the this convolution summation. Okay. Then associative property, H convolution of xn convolution of hn convolution of gn. Okay, it is equal to xn convolution of hn then convolution with gn. So this forms the associative property. And distributive property, xn convolution of hn plus g of n, which is equal to xn convolution of h of n plus xn convolution of g of n. So this forms the dissociative distributive property. Now consider an input signal xn equals to this thing and an impulse response hn equals to 2, 1. The convolution sum of yn equals to xn convolution of h of n is computed as follows. So I am sure most of you will not be able to understand. Okay. Now let's go to the next slide where I have created the example for you to have an understanding what we are doing in convolution. Okay. So we are given with xn, we are given with hn. Change the color of this. So xn and hn we are given with. So xn, if there are no these arrows, that means n equal to 0 is at this position, 0, 1, 2, 3. Over here also it is 0, 1, 2. Okay. Now I have to find out y of n. Y of n, it is given by x of n convolution of h of n. Okay. Now as we have already discussed, we have this h of minus n we have to calculate from the h of n. Okay. So across the origin we have to reverse the signal component, right? So we get h of minus n is equal to 1 to 1, where this last one it is the origin. Okay, we have got this. Now what you have to do is that you have to write this xn in its proper order, 1, 2, 3, 4 in this fashion. Okay. Then we have to match the origin of x of n and h of minus n. Okay. So see, this is x of n and this is h of minus n, right? So we have matched the origin values. These two are the origins. Now when both the origins they match, that means we are computing y of 0, yn equals to y0 when n is equal to 0. When both the origins matches with each other, then that means at that point n is equal to 0 in the output. You are getting my point? So y0, what is it? It is nothing but 1 multiplied by 1. Okay, 1 multiplied by 1 plus 2 multiplied by 0 plus 3 multiplied by 0 plus 4 multiplied by 0 plus 0 multiplied by 2 plus 0 multiplied by 1. So all these things you can eliminate and you get y0 equals to 1. Okay. Next, as we move h of minus n towards the right hand side, so there would be an increment of 1. There would be an increment of 1. So if I move this one at this location, so increment of 1 means I will be calculating y of 1. Okay. So y of 1, if you see over here, what it is? If you look over here, xn, h of minus n. So this was the origin, this was the origin. I have moved the values one step towards the right hand side. So now we are getting 1 multiplied by 2, which is 2. 2 multiplied by 1, it is again 2. So 2 plus 2 equals to 4. Got it? Now, pardon? 0 to 0 hai. If you want, you can write it. Otherwise, no need to write that thing. 0 means kya? There is nothing. Yeah. 1 n shift, because n varies from 0, 1, 2, 3, 4 up to infinity 8, 3, 2. Okay. So if you, from the origin position where both the origin matches, if you shift h of minus n towards the right by 1 unit, then you get to y of 1. If you move by unit of 2, it would be y of 2 and so on. So if you see from y1, y2, y3, y4, y5, we have computed and we have got the values. Okay. Thereafter, if you again try to increase it, you will see you are getting values of 0, 0, 0, 0. Okay, y6 equal to 0, y7 equals to 0, and so on. So you have got these values over here. Yn equals to 1, then 4, then 8, then 12, then 11, then 4. See, and what is the origin? Y of 0 was the origin, so this is the origin. Are you getting it? Now next is, if you look over here, what is the length of y of n? Length is 1, 2, 3, 4, 5, 6. Okay, we are having a length of 6, right? So if you see the length of x of n, 1, 2, 3, 4, length of hn 1, 2, 3. So we are having 4 plus 3. यहाँ पे if you see we have got only 6, that means minus 1, it would be 6. So if you generalize it, length of y, it would be equal to length of x plus length of h minus of 1, that would be your 6. Okay. Now if you see both xn and hn, they were having the origin at the first value itself. What happens if my origin was at 2? Again, we start with y0, y1, y2, y3, y4. The values, if you see, 4, 8, 12, 11, 4, 4, 8, 12, 11, 4. But in this case, what would have happened? If you look over here, we look over here, so what will happen? Towards the left also, you will be getting some values, right? We didn't get it. So our one values are 1, 2, 3, 4, and this one is 1, 2, 1. So this is the origin, this is the origin, right? So initially we are moving towards the right itself, because on the left hand side of the x there was no value. So we are just going towards the right hand side. But herein there are values on the left hand side also which we did not compute. So if we move 1 unit towards the left hand side, then there will be a decrement. That means we are getting this y of minus 1, and it is 1. So if you see the value, it remains the same, 1, 4, 8, 12, 11, 4. If you look over here, the value, it remains the same. However, what is happening is that the origin, it is at the second position. Okay, the origin is at the second position and we have to mark that. So how do you find this one? So see, if you see over here, I have written nx, capital N x, it is equal to 2. That means the number of values that are present after the origin, it is 1 and 2. Okay, in the case of xn. Similarly, n of h, the number of values after the origin value is 1 and 2, right? So nx equal to 2, nh equal to 2. So if we combine these two, we get 4. Okay. Now how it will help us in getting to the origin value? Because from here, if you see, we will start to count. 4 is 1, 2, 3, 4, after the 4 values, we will be putting the origin. It will be having the origin. Because over here, what we are doing, we know that we have to match the origin and then we have to compute all the things. But it is a quite tedious process. Okay, we don't want to go with that, because when you go for the other methods, you will find, say for example, the tabulation method, the computation is quite easy, but how do you find out the origin and what should be the length of the signal? That you don't know. So because of that, I'm telling you how to compute where to place the origin and what length of the signal you are expecting. If there is any mistake on these things, that means what is the length of the signal, output signal, then that means you have done something wrong in your numerical and you should revisit the numerical again. Okay. So the next method is tabulation method. The first method, it is called the sliding tape method. Okay. So if you see, we talked about sliding here, slide the flipped sequence across the input xn. Okay, so hence it is called sliding tape method. In inchy tape, what you have, you are having the value 0, 1, 2, 3, 4, like that. Okay, so hence it is called sliding tape method. Next is the tabulation method. So in the tabulation method, if you see, it helps us in performing the linear convolution. Okay, so in the linear convolution by the matrix, by the tabulation method, is xn is 1, 2, 3, 4 and h of n is 1 to 1. Okay. Now you multiply 1 multiplied by 1, 1, 2 multiplied by 2, this 4. Again, if you take it in the row wise manner, 1 multiplied by 1, 1, 2 multiplied by 1, 2, 1 multiplied by 3, 3, 1 multiplied by 4, 4. Similarly, in the second row, you have 2 multiplied by 1, 2, 2 multiplied by 2, 4, then 6, then 2 multiplied by 4, 8. Similarly, you get 1, 2, 3, 4. Okay. Now, what happens? Diagonal line, if you pass through this, so you are getting 1. Okay. Then you are having 2 multiplied by 2, 4. 2 plus 2, 4. Then you add this one, 1 plus 4 plus 3, 8. Here 10, 12, then 8, 3, 11, then this 4. Okay. So this is the linear convolution method. This is the linear convolution method. Okay. By the tabulation method. There is another method where you have circular convolution. Okay. So what you have the signal. The last method I have showed. By that method you can find out. If you see, this is the origin. If there is nothing, I have told you that first value would be the origin. If I put a mark at the second position, then this 2 would be the origin, n equals to 0. Okay. But since there are nothing given over here, that means at the first value, these are the origins. So how do you find out? 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. After 5, this is the value. Okay. And length is L of x, h of x minus 1, 4 plus 3, 7, minus 1, 6. So 1, 2, 3, 4, 5, 6. Okay. Now if you look into this circular convolution, so what happens? You write 1, 2, 3, 4 xn value. Okay. So we are having 4 components. So we have to develop a matrix of 4 by 4. Okay. Then next one would be this 4, it would come up and then sequentially you write it down. 1, 2, 3. Then this 3 comes over here. Then you write it down. Then this 2 comes over here. So if it is a 5 by 5 matrix, then if the length of the xn is 5, then you have to make a 5 by 5 matrix and so on. Okay. Similarly, if you see h of n, it is 1 to 1. So the length is smaller than x of n. So we have to pad the signal with 0. Okay. So this would be 4 cross 1 matrix size. Okay. Suppose herein we had say another 0, then 5. Okay. That means the length of the signal is 1, 2, 3, 4, 5. And over here the length of hn is only 4. So then we had to pad xn with 0. Okay, so that if you look into here, these numbers, these should be same. These rows in both the cases, these should be the same. Okay, the rows in both the cases, these should be same. Accordingly, you have to pad the signal. Herein, the length of xn was greater, hence we had to pad hn with 0. Then you perform the matrix multiplication, and if you do this thing, we get an yn of this thing. But this is not matching with the linear convolution what we conducted, right? So what we discussed, this convolution, this output, it needs to be found out by linear convolution method, because we discussed that our systems are LTI system, LTI. Okay, so here we are implementing circular convolution. So this method, circular convolution, is not appropriate for determining the output of the LTI system. However, there is a way to overcome this problem, and that method, it is regarded as linear convolution by circular convolution method. Linear convolution by circular convolution method. Over here, what we need to do is that we'll be implementing circular convolution, but we'll be implementing in a way such that we are able to perform the linear convolution. So what is the way around? We need to find out what should be the length of our signal, Y, output signal. Okay, so we have calculated it to be 6. What we have done, our signal length is 4, so we have padded it with zeros. So next step क्या है, यहाँ पे जाओ, then this goes like this, and so on. Okay, then accordingly, since both the rows, this should be same, so 1 to 1, then we padded it to get this row of 6. Okay, in HL. So we have to pad 3 zeros, right? Now you perform the matrix multiplication and you get the output, which is same as that of the previous two methods. Okay. Still now I have not gone beyond multiplication and addition. Okay, and we are almost half into our course. Okay. It is just a method. So circular convolution, usually it is not used in practical applications over here, but sometimes what happens, the calculation and all these things, it becomes easier. So hence circular convolution, it is being used in a modified format to implement the linear convolution. Okay. It is not as such used in DSP or DIP. DIP means digital image processing. Now coming to XN, again we are given with 1, 2, 3, 4. Okay, h of n 1 to 1. Here if you see, I have changed the signal. The signal is same, but I have changed the origin just to give you an understanding what is happening. So we have discussed that yn is given by yn equals to summation of m equals to minus infinity to infinity x of m multiplied by h of n minus m. लिखना लिखना नहीं है, फिर नेक्स्ट टाइम कॉपी ये करेंगे तो ब्लैंक जाएगा, वहां पे नंबर कट जाएगा. ओके, एनीवे. So now what you have to do is that there are two components. One is small m, one is small n. So these values we want to find out. If you see this small m, it varies from minus infinity to infinity. N can also vary from minus infinity to infinity. So will you calculate from minus infinity to infinity? No, because everything is limited, time limited, right? So you need to find out the values for these limits. For what would be the m limit, what would be the n limit. Okay, so how to do it? For this thing, this for the m values, what you have to do is that xl you will take, इसका time component क्या है? -1. If I would have given the component from here, it would have been 0, because then our n value would have been 0, 1, 2, 3. And if you remember, we started with y0, y1, y2, y3 like that. Now can you correlate it? So if for the m value, m lower limit, it would be the n value of the x, n value of the x. Okay. Similarly, the h value would be also the n value of the x, 0, 1, 2. Is it okay? No? You have to find out this minus infinity to infinity. You look at xn, you calculate or find out what is the n value for each things. So this is -1, this is 0, 1, 2, n value, time index value. So time index value, whatever would be the lowest one, it would be the ml, and whatever would be the highest one, it would be here 2. So basically what I am trying to say, m will vary from -1 to 2 instead of minus infinity to infinity. Okay. Next is n value. Over here also there would be one lower limit, there would be one higher limit. Okay. So how do you find out? NL, n का lower value, this n का lower value, it would be XL का lower value, XN its lower value, and H of n का lower value. So -1 plus 0, -1. Right? यहाँ पे थोड़ा confusion होगा, but this is the part you have to remember. When you have to calculate m value, we have to only consider the values related to the x. Its lower time unit value, it would be the lower one, and its higher one would be the higher. From the x it is calculated. On the other hand, small n for Nagaland, okay, So what we have, n value will be computed from the time index value of both x of n and h of n. So XL would be addition of n value of x of n and h of n. So -1 is the lowest time index value of x of n. So this is -1 and 0 is for the hn, lowest time index value. Okay. Similarly, for n of h, here we are having 2, here we are having 2. So 2 plus 2, 4. Got it? So what we have now, our m, it will vary from -1 to 2, and our n value, it will vary from -1 to 4. Okay. So if you see our equation, this equation, it has been modified to this one. Y of n equals to summation of m of -1 to 2 x of m multiplied by h of n minus m. Okay. Now for finding out y of -1, this is n. Okay. Summation of m equals to -1 to 1 x of m h of n value -1, because here n value we have taken as -1 minus m. Now just expand this, x of -1, because m is -1, x of -1 multiplied by -1 minus of -1 matlab h of 0, and again you open up all these things, so you get this value. Okay. Similarly for y0, n is 0, so this, if n is 0, so we get h of -n, right? Again you open this up, this thing, then similarly you go for y1, y2, y3, y4, you get this value. Y0 is in the second. Which one? Uh, no, 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 no. Y of -1 we want to calculate, because we said that our n value, it will be varying from -1 to 4. Since it will be varying from -1 to 4, the lower limit is -1. So here we have put y of -1. So what is this y of -1? It is nothing but y of n equals to y of -1. So basically what we are saying? We are saying that n is equal to -1 for this equation, right? Now this is n, we have just put the value of n. In the second case, n is equal to 0, -1 के बाद 0 ही आएगा, right? So n is equal to 0, so this is basically 0 minus m. We have just placed the value of n. xm, again you have to take these values, na? X of m is -1, x of -1 multiplied by, यहाँ पे क्या हुआ, x of 0. So what is x of -1? You check, x of -1 is 1 multiplied by h of 0. H of 0 is 1 plus second component x of 0, because m value is changing, आपने -1 कर लिया, now it is 0 multiplied by h of -1, because 0 m equal to 0 in the second case. Over here m equals to -1, here m equals to 0, here m equals to 1, here m equals to 2. See, we have moved from -1 to 2. m equals to minus 1, m equals to 0, m equals to 1, m equals to 2. Okay. Similarly, over here when you do it, we have placed the value of n in the second instance, right? N is equal to 0 we have put. Now, in this case, m equals to minus 1, m equals to 0, m equals to 1, m equals to 2. In the third case, what you will be having? N equals to 1, again m equals to minus 1 put करना है इन दोनों में, m equals to 0, m equals to 1, m equals to 2. So all these values, if you see, you are getting from here. What should be the lower limit, what should be the higher limit, and again NL and NH, small n, it will be varying from minus 1 to 4, minus 1, 0, 1, 2, 3, 4. Got it? So rest we will be discussing in the next class. This is the normal convolution here. There is, it is a linear convolution. It is a, no, if you don't mention anything, or if you write that find out the output of the thing by carrying out this what do you call linear convolution as per the convolution equation. So if you give it as per the convolution equation, then you have to find out all these equation parameters and then you have to do it. And the other thing is, first one is sliding tape method, second one would be the linear convolution, third method would be the linear convolution by circular convolution method, and last one will be, we will be giving you the example, by performing the by using the linear convolution method or the linear convolution equation. Basically, this is the main equation I showed you at the last, because you can understand what is the physics. In books, you will be finding it in other way. First, they will discuss about the equations, and then they will discuss about the other methods. But I told you in this way because first you grasp the what is happening over there, understand the basics, and then I have entered into the equations. Okay, and again over here there is nothing more than multiplication and addition.